For the sand cone test, which is an in situ test or an on-site test, we use the sand cone with the bulb that has the sand that is used in it. The ASTM requires that you have a uniform sand. In this test, we had a deviation from the ASTM in that we had a sand that's been used previously for this test, so it's been sieved through the number 20 sieve. So we assume that it's uniform, but there's a deviation from the ASTM. First, to calibrate the sand mold, the cone mold, we place the entire apparatus onto the scale to find the exact mass. Next, the sand cone is inverted on the base plate, and the valve is opened. Hit the apparatus gently to make sure that the entire sand cone is filled with the sand. Once the sand cone is completely filled with sand, the valve is closed and the sand cone is lifted up.
Then add enough water.
Now, because we know the uniform density of the sand that was in here, and the base plate was placed on a level surface, we can use the density and the difference in the masses to calculate the volume, the actual volume of the cone itself. Now we measure the mass of the sand cone apparatus again, record this value, and we take the difference between the two, and that is the mass of sand that went into the sand cone itself. After calibration, we take everything out into the field where the tests are conducted. Before we go, we make sure that the mass of the sand cone is measured once again, and we make sure that we measure the mass of the bucket with the lid that we're going to use for the soil sample. We clear off the space that's level and that is representative of the entire sample that we're wanting to test. Then we make sure that the base plate is level. We then use a spoon to dig out the sample, making sure that it stays even with the edges of the base plate, the circular portion, which will not actually be conducted for this example, but will be done in the field. Make sure that all of the soil that is removed from the hole is put into the canister, and then after all the soil is removed, the top cap placed on immediately so that no moisture is lost. After this is done, the sand cone is inverted once again over the hole, and the valve is opened. The sand is allowed to go down into the hole as well as the sand cone, and then after this is done, the valve will be closed once again and the apparatus removed. The mass of this will be recorded once again, and we can, as before, find the mass difference between the initial and the final, and be able to calculate the volume of just the hole by subtracting out the volume of the sand cone itself determined previously. This will then be taken back, the soil sample, and a moisture content analysis conducted, as well as before that is done, the mass will be taken so that a unit weight can be determined based on the mass here determined and the volume determined here.
First, make sure that the nuclear density gauge is at least 10 feet away from any buildings or obstructions. Then, with the standard block underneath the nuclear density gauge, press for the standard count. Then step away at least 3 feet and wait 4 minutes. Once the standard count is completed, this gives us the moisture standard count and the density standard count. These values are then compared to the average of the last 4 recorded values in the logbook. The density standard must be within plus and minus 1%, and the moisture standard must be within plus and minus 2%. Next, the gauge is taken into the field, and the base plate should be used to clear a level surface for testing. Place the base plate down and make sure it is secure. Next, put the spike through the key and put the spike into the hole used for testing. Step on the base plate to make sure it is secure and drive the spike down to the desired testing depth plus 2 inches. Use the key to remove the spike from the hole. Then use the spike to mark the edges of the base plate so that the position of the nuclear density gauge will be able to be determined once the base plate is removed. Also mark the exact position of the hole, as this will be where the rod of the nuclear density gauge will be inserted. Then remove the base plate. And after doing so, place the nuclear density gauge in position. Pull back the trigger on the handle of the rod and insert the rod into the hole to the desired test depth. Next, snug the nuclear density gauge against the side of the hole so that there is no space. Hit start and move 3 feet away. The reading will conduct itself for 1 minute. After that minute, move back into position, pull the trigger, and remove the rod from the hole. Read and record the wet density, the dry density, and moisture content readings. Use the keypad to locate these.